Hello everyone, and welcome back to the quiz review part 2. In this video we will be covering number 15 through the very last problem in your packet, number 22. So this is the second video. If you're watching this first, please go to the other one so you can watch numbers 1 to 14. All right, number 15 looks like we have an equation with many variables on both sides. And so our goal is to distribute and simplify combined like terms on both sides before we move a thing. So here, if we distribute, and this side, if we also distribute, let's focus on the left side first. The negative 3x is not being distributed. So now we'd have a 5 times 2x, which would be 10x. 5 times negative 1, which would be negative 5, equals 4 times 3x is 12x. 4 times negative 5 is negative 20. Negative 5 times x is negative 5x. But be careful. Negative 5 times negative 3 is a positive 15. I don't know about you, but this problem looks a little bit too messy right now to move any variables yet. So what I'd like to do is combine like terms. So negative 3 plus 10 on one side is a positive 7x minus 5 equals, on the other side, the 12x and the negative 5x can be combined, as well as the negative 20 and the positive 15. So on the right side, 12x combined with a negative 5x is a positive 7x. A negative 20 combined with a positive 15 is a negative 5. So I have 7x minus 5 equals another 7x minus 5. So if I wanted to treat this problem like the ones we've been doing, we would want to get our variables together. So you would subtract 7x from both sides. They combine to be 0 here as well as this side. So we'd end up getting negative 5 equals negative 5. Now this time, this statement is absolutely true because negative 5 is always equal to itself. So that means if this statement is always true, that means that I could plug in whatever x value I wanted every time in this equation, and this side would equal this side. So I could plug in x equals 1, and this side would equal this side. X equals 1,000, this side would equal this side. X equals 2/3, this side would equal this side. So my answer is all real solutions. The symbol for that is a double bar R, or another way, a double barred R. To do that again, you make 2 lines and then make a capital R. So this symbol is the same thing as all real solutions. Just make sure your final answer is true. Moving on to 16 and 17, your goal is to write an equation for each sentence, and then we do want to solve. So 16, 2 is subtracted from a number. So this means that the number that we don't know, x, was there first, and then 2 is subtracted from it. So I'm going to write x minus 2. And then the difference. We just wrote down a difference because remember, difference means subtraction. So this difference is multiplied by 5. And because we want the whole difference multiplied by 5, we need parentheses. And the result of this, result is meaning equals 30. So this is the answer for your equation. However, if you wanted to keep solving it, which I'm asking you to, we would have to distribute. And if we did distribute, we would get 5x minus 10 equals positive 30. Add the 10 on both sides. Sorry about the room here. We get 5x equals a positive 40. Divide each side by 5. So x looks like it is a positive 8. Number 17, 5/6 of multiply a number is negative 5/9. Is always means equals. Of always means multiply. So I'm going to write my equation down here. 5/6 of times a number, I don't know what it is negative 5/9. So this would be your answer if I just asked for the equation, but we have to multiply both sides by the reciprocal because we are multiplying, or we are really wanting to divide 5/6 to the other side, but the faster way is to multiply by the reciprocal. So that's what I'm going to do here and here. 6's cross out, 5's cross out. X equals -5/9 times 6/5. There's two ways you could do this problem. You could either multiply across and get -5 times 6 and get -30 over 45. And you could keep reducing. You could divide these both by 5 and get -6/9, and then divide these both again by 3 and get an answer of -2/3. So your answer is -2/3, but some of you might have noticed that if I went back to this step, we did have a 5 on top and bottom, so you could cross those out here. You would end up with -6/9 directly, and then you just have to reduce it once instead of twice. So it is your choice, whichever way you see first. Consecutive integer problem. I wanted to do at least one on the review to make sure you know you should study this. The sum of 3 consecutive even integers is 102. So remember, sum is addition. Consecutive even integers on a number line look something like 2, 4, and 6. These are all even integers that are close to each other on the number line. And all of these are only 2 units apart. So from here to here is 2 units, and here to here is 2 units. So if we didn't know that this first number was 2, we could call the first number x, the next number 2 units farther, or x plus 2. Then the next one would be 2 more units farther, which would be x plus 4. So I like to be organized, so I'm going to call the first number x, the second number x plus 2, because even numbers are 2 numbers apart, and the third number x plus 4. And if I know that the sum of 3 numbers is 102, I could say that the first number plus the second number plus the third number equals 102. Or if we substitute, the first number is really x. So x plus the second number, x plus 2, plus the third number, x plus 4, equals 102. If we want to simplify this side, I see that we have some like terms. 3x plus 6 equals 102. Then this looks like I can just kind of solve from here. Subtract the 6. 3x would equal 96 if I subtract 102 minus 6. If I then divide both sides by 3, sorry about that. If I divide both sides by 3, I would get x equals 32. But that has not answered the question yet because x just represents my first number. So my first number is 32. My second number is 2 units farther, 34. And my third number is 4 units from the first, or 2 units later, or 2 units after the second number. So my numbers are 32, 34, and 36. So I'd like to point out here that the question asked for 3 consecutive even. Make sure that your answer is truly 3 even numbers that are next to each other. Otherwise, you know your answer is not correct. I also want to point out that if this had odd numbers instead, or odd even integers, this process would be the same, because remember that on a number line, 1, 3, and 5 are consecutive odd, and they are also 2 units apart. All right, last types of problems, the literal equations when we are solving for a variable and getting everything else to the other side. So number 19, my goal is to solve for x, or to get x alone. So if we looked at 19, we have x and b, we have a and b on the same side of x. B is the least attached, so I'm going to get rid of that first. So I'd have ax equals 4c minus b. 4c and b are not like terms, which is why we cannot combine them and why we have to write them separately. My next move to get x alone is to get rid of that a, and a is currently being multiplied. So we can divide by a and get x equals 4c minus b, all divided by a. Some of you might remember, though, that you could split this up into two fractions to get 4c over a minus b over a. Either answer is great. Number 20, I notice that I do have a giant fraction, and the y is causing the problem, and that is the reason the fraction exists. So just like a couple earlier problems, I am going to multiply both sides by y first, cross these out, get 4m plus 3n equals 7 times x times y, which you can just write as 7xy. My goal is to get m completely alone, so this 3n has nothing to do with the m and is not attached. So I'm going to subtract 3n to the other side. So I'd have 4m equals 7xy minus 3n. The last thing that's keeping m not alone is the 4. So I would divide both sides by 4. And so final answer could be 7xy minus 3n all over 4. And yes, like the last example, you could write this as 7xy over 4 minus 3n also over 4, but I just decided not to this time. Last two examples. Number 21, my goal is to get w alone. So I notice that the x is not attached, so let's move that over by adding. So we'd have 1/3 w equals 5y plus x. Again, not like terms, cannot combine. To get the 1/3 over quickly, let's multiply both sides by the reciprocal. But both things on this side both need to be multiplied by 3/1, so we need parentheses. Here, these cross out, so we have w equals 3/1 is the same thing as just 3, and I know that a lot of you would prefer the 3 in front when you distribute, so feel free to change that. This answer is okay, but I'm sure a majority of you would want to distribute, so a good final answer would be 3 times 5y, 15y, plus 3x. W is isolated, so I know I'm done. Last but not least, we have number 22, where every example so far, we have only had one of the variable we're trying to solve for, but this time, if we're trying to solve for x, I know that there's an x on this side and an x on this side. So my first step would be to get the x's together on the same side at least. So if I do that, the bx's cross out. I would have ax minus bx minus y equals negative w. Now, I still want to get the x's isolated, so I notice that the y can be moved to the other side. So let's add y on both sides. Cross these y's out. You'd have ax minus bx equals negative w plus y. Now, at this point, we talked about that. Both of these terms have an x, and we only can solve for one x. So we need to get from two x's to just one. And so what we did was use the distributive property backwards, or took out a greatest common factor of x. So if I took an x out of both terms, if I took x out of ax, I'd be left with a. X out of negative bx, I'd be left with negative b equals negative w plus y. Now that I have one x, I can legally divide both sides by a minus b. Cross these out. So x is finally isolated, and my answer is negative w plus y all over a minus b. Okay, so this is my final answer for 22. Feel free to go back and rewatch any problem you may need. I hope this is a great studying resource for you. Thanks, guys. I will see you tomorrow.